And welcome, AP Economics students. Today we are looking at an old free response question from the 2016 macroeconomics exam. So let's see what they are looking for. The statement says, assume that the United States economy is currently in a short-run equilibrium with the actual unemployment rate above the natural rate of unemployment. So there's your hint about what's the status of the economy. So just a quick review here. There's going to be three situations they want to know. So these are very light sketches. This is of the ADAS model. Either the economy is in equilibrium and all is good, or it's possible that the economy is in a recessionary gap, because this is the cold side. So remember, this is the cold side, this is the hot side. Or we could have an economy that is too hot. It's on the hot side, and we have an inflationary gap. So we could have the inflationary gap, we could have a recessionary gap, or we could have we're at full employment. Everything is all good. They might say full employment. One of those three things is going on. Well, let's think about it. If we're in a recession, which means our unemployment is going to be higher than normal. So in this situation, unemployment would be high. And in this situation, in a really hot economy, unemployment's going to be low. So they're giving you that little clue. Now, if you would like, you could be thinking of the Phillips curve too, but most students start with this, and that leads them to the Phillips curve. And since I brought that up, the Phillips curve analysis here, for the Phillips curve, if everything is all good, there is the point. If you're on the cold side, if you remember these are horizontally opposite but vertically the same, if you wanted to, so up here, instead of being cold hot, it's the opposite, so it's hot cold like that. So if you have a cold economy and you're in a recession, that means you're going to have a point over here. And again, they usually give you a point to refer to because we have a cold economy. And if we have so I'm going to say this is a recessionary gap. So this is a recession, and we have unemployment is high. And over here, on a Phillips curve, we would put a point over here on the hot side, and this would be an inflationary gap, and the unemployment is low. Well, there's another basic reason why you could have concluded that is, don't forget, this is the unemployment rate. The horizontal axis is unemployment, vertical is inflation. So if this thing says we have unemployment is high, well, we're going to be over farther down the axis. It's going to be this one. We're in a recession. It's got to be. But then also in this one, it says we have a lot of unemployment, cold economy, we're in a recession. So of our options, this is kind of what you should be thinking. So sometimes it's good to just sort of think through it, make a quick sketch, and if you have to make a really nice graph, you can do that when the time's called for. But for right now, you want to think, okay, I got it. We're in a recession, high unemployment. It's above the natural rate. Don't forget, the long-run Phillips curve is at the natural rate of unemployment. So we're higher than the natural rate. So cold economy, things aren't going well. All right, so that's our situation for this question. So let's see what they want us to do now. So this is just scratch work over here. So it says draw a single correctly labeled graph with both the long-run Phillips curve and short-run Phillips curve. Label the current short-run equilibrium, point P. So it turns out they wanted a Phillips curve anyway, so we have a quick little sketch here to help us out. So we'll make a nice graph. Let's use a straight edge here. We'll just make a nice graph. These are relatively simple graphs here. There is our short run, and then we have the long run. All right, and I'm going to label this one right here. This is going to be our LRPC, because that's our long run Phillips curve, and this is our SRPC. Right here, I'm going to label this axis unemployment rate. The vertical axis is inflation. Okay. and we have to put our point P, representing that we're in the recession, so I'm going to put a point right there, and I'm going to label that P. I think we have that. Okay, so we have our Phillips curve labeled, everything is labeled correctly, and we've got our point there. Okay, now part B. Alright, so I'm going to get rid of these, except for these two here. Now I already have this one drawn, so I'm going to get rid of these over here, and then I want to focus on this cold economy over here. Alright, so I'm going to draw that one a little bigger, just for this sketch here. So we know we're in a cold economy. We have a recessionary gap. Okay, so we've got a recessionary gap to some degree here, and this is our short-run aggregate supply, long-run aggregate supply, and our AD. And this is just scratch work that can just help us kind of figure this out. So it says, point B, assume no policy actions are taken. Will the short-run Phillips curve shift right, left, or remain the same in the long run? All right, so let's look at this one, because this is usually we analyze what's going to happen if we do nothing. Now, what's interesting is it says if no policy actions are taken, you should be thinking, what should come to mind is a little Austrian school or Hayek approach to things, and you just say, just let it go. In the long run, things will correct. Okay, so this is a very non-interventionist, non-Keynesian, very Austrian school Hayekian approach. So what's going to happen in the long run? Well, eventually, the resource prices are going to get cheaper and cheaper, just like when there's a downturn in economy, like the housing market. Eventually, house prices find a bottom, and eventually it's low enough that people re-enter. So what's going to happen is eventually, if no policy actions are taken, eventually resource prices will be low enough that there will be an increase in SROS. Okay, with no policy. Now remember, if we intervened in the economy, that would shift the aggregate demand. That would be aggressively closing the gap with intervention. But no intervention allows the SROS to move. And it would move back here. This would be SROS prime. Okay? And if that moves back to this point, if you recall, since the short-run curve is moving, if you remember on the Phillips curve, there's two, you stay on the curve, so I'm just going to jot that. If AD moves, then you stay on the SRPC and you just move along it. Okay? But if SROS moves, you shift the SRPC. Okay? So in this case, it was the SROS that moved to the right and down. Well, remember, in the difference between ADAS model and Phillips land is horizontally opposite, vertically the same. So I have the entire SROS curve moving to the right. That means that the entire curve is going to move to the left. So that would move this thing left. Now, I don't think we have to demonstrate, we just have to explain it. So it says, assume no policy action. Yeah, we just have to write it. So what happens? We would say the SRPC shifts left. Now we have to explain why. Now you can't just say because the AD or the SROS shifted right. That doesn't work. We have to explain it from an economic standpoint. Why, if we do nothing, does eventually this change? Well, here's what we were going to say. Eventually, resource prices are low enough for businesses to supply more and hire workers. Okay? But it happens eventually. So why is eventually this going to move? Because eventually businesses will, resource prices are low enough, businesses will hire and supply more, which will increase there, which is going to lower the unemployment. So when they hire workers, that lowers the unemployment, and that's why we get back. But so that tells us why we're moving to the left. Businesses supply more and hire workers, and you could make a comment about when you move this way. You guys want to notice what happens to inflation here. Price level drops when it goes this way. And you could say you could hire workers at a lower inflation rate. Okay, so the only way you can, if you were to stay on the curve to get here, you'd be a higher inflation rate. So staying the lower inflation rate is important. So we went left because we're hiring workers. So that got us going left, and what made us go down? A lower inflation rate, stating that. Okay, Part C. Let's see. See if we can sneak that in here. All right, Part C says, if the Federal Reserve Bank wants to lower unemployment, what expansionary open market operation should it use? All right, good review here, too. All right, so let's get rid of this, and now let's just think about this is a monetary policy question. So remember, there's the monetary approach and the fiscal approach. This is a monetary approach question. So if you are in a cold economy and you want to fix this with monetary policy, okay, pretend you are Jerome Powell. You have 3 tools in your tool belt: the reserve ratio, the discount rate, and open market operations. Okay, so monetary policy, if you want to stimulate the economy, you lower the reserve rate, you lower the discount rate, and you buy bonds to increase the money supply. Now, just to review this with a sketch, this is not required here, but remember, when it comes to the money market, the money supply, I'm going to put S sub M, this is controlled by the Fed. This is our nominal interest rates here. This is our quantity of money. Okay, so this is our demand for money. All right, so what stimulates an economy? Low interest rates, because when interest rates are low, you'll borrow money to buy a car, buy a house, businesses will borrow money to expand. So buying bonds increases the money supply, which lowers interest rates. Okay, so what monetary policy are we going to use? We're going to buy bonds. Remember, buy. Remember the alliteration. Buy means bigger money supply, lower interest rate. So what open market operation? Buy bonds. Okay, don't even have to explain it, just that. Okay, so now let's go to D up here. D says, excuse me, D says, how will the open market operation you identified in Part C affect each of the following? The federal funds rate, and then explain. Okay, well remember, the federal funds rate is that annoying rate that sure sounds like it should be the discount rate, but the federal funds rate is the rate that banks charge to borrow from each other. And the federal funds rate follows the discount rate. So that's all we would say here. So how will it affect the federal funds rate? It will decrease. So I'm going to say the federal funds rate will decrease as it follows the discount rate. Okay, and that'll be good. That was 1 on Part D. Part 2 of D says, what happens to real interest rates in the short run? Well, real interest rates, I want to review that formula for you. Remember, this says nominal interest rates, okay? But in the short run, whatever nominal interest rates do in the short run, real will follow. So if you remember your formula, real interest rates are equal to nominal interest rates minus expected inflation. Okay, expected inflation. So I want to give you an example. Let's pretend the real interest rates out there, real interest rates are 6%, we'll just pretend. Because the nominal interest rate is 8% and inflation is 2%. Okay, that would be just an example of our equation. Well, let's just pretend you lower nominal interest rates. If you lowered this to 5 and took 3 away from this, all of a sudden you're going to have 5% minus, you still have 2% here. Well, if you dropped this by 3, you're going to have to drop this by 3. Okay? So what happens to real interest rates? They fall in the short run with nominal as well. Now, there's no additional information here about inflation, which could have made this trickier, but it's just it decreases. All right, and then we are to E. Given your answer in part D2, the one about decreasing, what is the effect on real gross GDP in the short run? Explain your answer. All right, this is a very, very important question. So let's get this out of the way, and let's discuss this. This is super, super important here. Now, the reason the monetary policy kicks in here to fix these recessionary gaps, it's always this little sequence of events. Whenever there is a lowering of interest rates, what that leads to is an increase in consumption, and it leads to an increase in business spending, which is what I is. So you can't ever forget that aggregate demand here is C plus I plus G plus NX. So if interest rates are down, it leads to an increase in consumption, increase in aggregate investment, and it also leads to, therefore, an increase in aggregate demand. Well, it's going to lead to an increase in aggregate demand. Now, remember, the second part of this question said, how would you do on monetary policy? So originally we were talking about doing nothing and talked about how SROS would move over, but I'm going to take that out of there. Let's get back to being just in a recession. If it's interest rates that lower and we increase consumption and business spending, well, that's part of aggregate demand. That would move this over and we'd close the gap with that scenario. That's a different solution to closing the gap. Now you get people working, but you can notice you have a little bit of inflation here. That's the downside. So the pro to doing it this way is you more quickly fix the problem. The downside is you might have triggered inflation, and also you're probably in debt. The advantage to just letting recessions just run their course, the good part is it usually winds up with low inflation. The bad part is sometimes you have unemployment for a really long time, and you could lead to a whole lot of problems. Well, in this sequence of events that you want to have down, lower interest rates leads to consumption, increase in consumption and investment leads to an increase in aggregate demand. There's two little insertions here that I want to talk about that AP just loves. And here it is right here. Whenever there's a decrease in interest rates, what they love is this little expression that I'm going to put right here. Okay? What they love for that to be is this. An increase in interest sensitive spending. Okay? An increase in interest sensitive spending. Okay? Which includes an increase in consumption, an increase in investment, which leads to an increase in AD. Now, there's another phrase they like to do when you're going to be discussing the SROS shifting with just I, but we'll talk more about that later. That's called an increase in capital investment. Not as important for this one. So it just says, well, how's this going to affect everything? The federal funds rate is decreased. Well, you can write your shorthand here, or you can just write it a sentence. But so I'm going to write here a decrease in interest rates leads to an increase in interest sensitive spending and an increase in consumption and investment. Okay, now might as well get this out of the way now. Which leads to increase in aggregate demand and GDP. Because remember, aggregate demand is just a part of GDP, or is GDP, so that would be your explanation. Now, some people just actually leave this little shorthand here. If you have the time, just go ahead and write a sentence and just explain that. But decrease in interest rate leads to an increase in, and that's what I would actually write this, an increase in interest-sensitive spending, which is an increase in consumption, and investment, which leads to an increase in aggregate demand, which leads to an increase in GDP. Okay? So if you have the time, a sentence neatly written is better, but this shorthand is also acceptable. All right? Now, next question on here was F, and it says Japan and the U.S. are trading partners, and it talks about the foreign exchange. And this is not applicable this year. Question G says, a correctly labeled graph of the foreign exchange market, also not applicable this year. Okay? So, this question was an economy in recession, but we never actually had to draw the ADAS model. It actually focused on just the Phillips curve. And if this was a normal year, usually in part one has two graphs, and the other graph would have been the foreign exchange market, but you don't have to worry about it. So you'll probably have two graphs, but one of them won't be one you don't have to know. That makes sense. So a Phillips curve that was connected, though, to the ADS model and thinking through all the, we had a monetary policy issue, and we had a not do anything. There was no fiscal policy. But that's what we had. That's as much as we could do for this year. So that's 2016 number 1. Now, let's move on to number 2. Okay, question 2 is related to the idea about when monetary policy changes the reserve ratio, and how does that, what's the trickle-down effect within a bank. And so, whenever you see a bank statement question, it's really focusing on that little piece of information. So, the following is a balance sheet of First Superior Bank, and it lists the assets and it lists the liabilities and equity. And so there's all sorts of clues in here. It's just a matter of experience going through them that you'll figure out what means what. So I'm going to rewrite this a little bit bigger over here, and they have us just divided down, which is very normal on these. And they say, okay, here's our assets, and sometimes it's just liabilities, and sometimes they'll do liabilities and equity. And since there's no equity in this one, it's not worth discussing. So on this one, it says, all right, here is your reserves. Yeah. And under here is the loans. Well, right away, I want to point something out on here. It says the reserves are $200, and it says the loans are $1,800. Well, usually when it comes to reserves, there's two types of reserves. The two types of reserves are required reserves, and the other type is excess. So it's a little bit unusual that they didn't tell you which type of reserves, and that was right away a clue that they're going to have you figure out which kind it is. Now over here on demand deposits, so a demand deposit is equal to, on this one, $2,000. So when you see the word demand deposits, the reason it's called that is, what is the amount of money that at any one time a customer could demand? Well, you can demand all the money you put in the bank. So it means that all the depositors have put in $2,000. Now these are never realistic numbers here, so you just kind of play along. But pretend all the customers in the bank, all the deposits are $2,000. That's all there is. Okay? And then again on this equity statement, which we don't need to worry about for this question, is just 0. So with this information, what can we figure out? Okay, so this is where the focus of all the analysis is. Well, now let's keep reading. It says, assume that the required reserve ratio is 10%. Very important piece of information. So this is straight from the Federal Reserve, that the required reserve ratio. This tells us everything we need to know in order to do the problem. So it's 10%. Well, now what that does is it makes everything else make sense here. So if your demand deposits of all your customers, $2,000. Well, if the Fed tells you the required reserve ratio is 10%, 10% of 2,000 is $200. That tells me that what kind of reserves are these? These are the required reserves. These weren't excess reserves, they're required. It's $200. Now what does a bank do with the remaining money? It loans it out. So, really, what would have been better on this problem now that we've figured it out? I'm going to rewrite this a little bit. I'm going to adjust this very slightly. So I'm going to get rid of this, and I'm going to change the adjectives here. Okay, so what I'm going to do is I'm going to make this my required reserves are $200. My excess reserves are 0. And my loans are $1,800. This is really what they're implying. Now, they tried to make it a little tricky by not telling you the balance of the required versus excess. So just to explain, to give you an example, maybe this happened. It is possible, actually make that a little smaller here. It is possible on this problem, maybe when they wrote it, they could have said this, just to give you an example. They could have said, you know what, let's give them a problem where the excess reserves are 100. The required reserves are still, that's a given number, and then this is 1,700. Okay, they could have done that. And when you would have looked at it, you would have said, oh, well, this bank, because the required reserve ratio is 10%, they have to keep $200. That means they can loan out the rest, which would be $1,800, and they only have $1,700. That means they have another $100 they could loan out. They could have done it that way. They can always put money in excess reserves if they wanted. But on this particular question, they said, no, let's just not even identify both types of reserves, because you'll see other questions where they do have both of these listed. Let's just call it reserves and see if they know what they're doing and can figure it out. So that's what they did in this question. So I'm going to make this going to go back to 0, and I'm going to make this 1,800. Okay? All right, so let's see if we can now attack the questions and see what we got here. All right, so it says, for part A, it says, what is the dollar value of new loans that First Superior Bank can make? This actually has a little bit to do with what I was just referring to. How many new loans can we make? And the answer is none, because we have to have excess reserves to make them. So this question is illustrating this bank has maxed out its loans, which is good. You can't make any more. So the key word here is new. What's the dollar value of new loans they can make? 0. There are no excess reserves. Okay, part B. Mr. Smith deposits $100 of cash in a demand deposit account at First Superior Bank. So here's a new customer, new $100. Calculate the maximum amount of new loans at First Superior Bank can now make. All right, so here's what's going to happen. We have a new demand deposit. So here's what's going to happen to our balance sheet here. I'm going to make this a little bit smaller. But our balance sheet's going to get tweaked a little bit here. So here's our assets and here's our liabilities and equity. So if we have a new customer, that's going to increase our demand deposits. I'm going to do little abbreviations. That's going to increase this to 2,100. Okay? So what's that going to do to required reserves? Well, my required reserves are now going to be $210, according to the rules. Okay? And now I have excess reserves. I have an excess reserve of $90. And my loans right now are still, haven't made any new loans, are still $1,800. Okay? So if you'll notice, 90 plus 210 is 300. 300 plus 1,800 is 2,100. So look what happened to the new $100. The new $100 was divided up. Okay, so this new 100, I'm going to put this right here. The new $100, all of it went here, but over here we put only 10 into required reserves. Okay, we put 10 here, and we put 90 of it here. Okay. Now these always have to equal each other, by the way. Okay. So now that we've got $90 in reserves to play with, so it says Mr. Smith deposits $100. Calculate the maximum amount of new loans First Superior can now make. Well, now they have excess reserves. They can make $90 of new loans. Okay. And again, that's why up here I decided to make this the two types of reserves, because I knew we were going to have new reserves coming in. All right, part C says, as a result of Mr. Smith's $100 cash deposit, calculate the maximum change over time in each of the following in the banking system: loans and demand deposits. Well, if you recall, in macro, there are two types of multipliers. So this will just be notes down here. We had two multipliers. One of them was a spending multiplier. And if you remember, the spending multiplier related to marginal propensities to consume, marginal propensities to save, and that was used to calculate how much money will be multiplied through an economy. And so that was 1 divided by your marginal propensity to save, and that gave you your spending multiplier. The other multiplier was called the money multiplier, and that had to do with effects using monetary policy, and the money multiplier was 1 over the required reserves, and that gave you the money multiplier. Okay, so you want to keep those two multipliers straight. Well, in this setting, we're dealing with a bank. This is not propensities to consume. This was a banking question, required reserve ratio right here. So we have a money multiplier. So it's going to be very important on this one to account for that. So the required reserve ratio is 10. Well, what's also implied there is that the money multiplier, the required reserve ratio is 10%, which tells us that the money multiplier is equal to just 10, because it'll be 1 divided by 10%, which is 1 over 0.1. Okay, so that 10 is going to be really important. So now the question says, Mr. Smith's deposit of $100, how does that change over time the loans? Well, over time here, he's going to be able to loan out a new $90, but remember, the multiplying effect, not only is that $90, remember there was he can take out 90 and then he could deposit that in another bank, and then their required reserves is kept, and then they loan out the rest of that. This continual multiplying of that deposit, all you have to remember is that this, the excess reserves, is now going to get multiplied by the money multiplier. So over time, what can happen here is this can turn into $900 for the loans. Okay? Now, if just for notes here, just to keep this in mind here, so I'm going to erase this for right now. So the change in loans is always going to be this. This is little notes here. So what is going to be the change in time of loans? Here's what you want to remember. It's going to be the excess reserves times your money multiplier, and that'll be your change in loans if you ever get that question. All right. Then the next question says, what happens to the demand deposits? What would be the change over there? Well, he deposited a full $100, the full 100 in demand deposits over time, and that's the key phrase here, is over time. Over time, that entire deposit gets money multiplied by the money multiplier. So for part 2, it's going to be his full $100 times 10, and that would be a $1,000. Okay, so you also want to remember that the change in demand deposits, that calculation there is going to be your deposit times the money multiplier. So these two little things sometimes can trip you up a little bit. When do you include it, when do you not? And you just say, okay, for the change in loans, I only account for the excess reserves that were created with the 90. The change in demand deposits, I account for everything. Okay, and they oftentimes will ask that question. All right, D says, as a result of Mr. Smith's $100 cash deposit, calculate the maximum change over time in the money supply. Now, there's a little subtlety here. Now, this was in the banking system, this question. All right, so on part C, this was a banking system question. So I'm going to emphasize this, change over time in the banking system. Whereas this next question, D says, as a result of his deposit, calculate the maximum change over time in the money supply. Well, he deposited $100 multiplied by the money multiplier is 10. Here's the most common wrong answer. In fact, you may be thinking of it. It's like, oh, isn't it going to be the 1,000? Well, the answer is no, and here's why. The $100 deposit, that money already existed. So this is a change over time in the money supply. So we don't get to count his initial $100. The $100 was used to create 1,000, so 900 new dollars was created, and that was from the loans. So in the money supply, it's only the 900, and sometimes students get a little bit tripped up by that one. The reason it's not 1,000 is because the $100 was already existed. Okay. Then what do we want to E? We just have one question there, yeah. So E. Provide one reason why the actual change in the money supply could be smaller than the maximum change you identified in Part D. The best answer for this one is a bank may decide to hold excess reserves and not loan out everything. So it's not the greatest question, to be honest with you, but this works. A bank may decide to hold more excess reserves. So a bank is not required to loan out all of its money. In fact, maybe, remember, if by chance they have someone that comes in and requires all of their demand deposits and they don't have it, and then they have to borrow money from the Fed or from another bank, maybe this bank is in a location where there's a lot of people, short-term residents, and they, even though they make a big deposit to keep their money in the bank, they know they're going to leave within 6 months to a year. Just a lot of high transient population. Maybe you're near a military base, and a lot of people are only stationed there for a short period of time. So you decide to keep more excess reserves because you have a higher than usual demand deposit request to be withdrawn. So that's why it's an okay answer there. Okay, so there will be more of these bank sheets that we have to read, and this is a relatively simple one, but you want to keep in mind the idea of the required reserve ratio and how that affects the money multiplier, and the two biggies right here. Part C is probably the most important here. The change in loans is going to be that excess reserves times the money multiplier. The change in the banking system, the reason we get to count that initial $100 was it was inserted into the banking system. But the change in the overall money supply only back to 900. Those three can sometimes trip you up. Okay? So assets always have required reserves, excess reserves, and loans. And we'll stumble upon one later that has an equity statement in there that we'll talk about. Okay? So there is question 2. All right? Let's move on to 3. All right. Question 3 is a trade table question, and we're going to be looking at absolute advantage, comparative advantage. I haven't done these for a while, so let's see if we can figure this out. So first off, I'm going to recopy their trade table here just to make it a little bigger. And so it says the following table shows the number of donuts or cupcakes that John and Erica can each produce in a day. So it's production, so this is an output. They're not saying how much time or how much flour or sugar. It's just how many cupcakes can they produce. So we've got John and Erica, and we've got the donuts here. Just put Don, and we've got the cupcakes here. Okay, and I'm going to rewrite the numbers. I'm going to put those off to the left side here so that I can find their per unit opportunity cost a little bit easier. So I've got 200, and Erica makes 150. And for cupcakes, John can make 100, and Erica can make 50. So I'm going to disregard the questions for now. Let's just figure out who's got the comparative advantage, who specializes, and and then we'll continue from there. So remember, since it's an output, we're going to use our shortcut of other goes over. So 100 over 200 is a half, so that tells me that 1 donut is equal to half a cupcake. And we can just throw the reciprocal over here, or we can do other goes over again, but it's going to be 1 cupcake for 2 donuts will be our ratio over here. And then for Erica, other goes over. This is pretty nice fractions here. We have 1 donut for 1/3 of a cupcake. And over here we're going to have 1 cupcake for 3 donuts. So you can say 4 equals or costs, whichever. Okay, and so then if we look at it, remember when it comes to absolute advantage, it's just who can make the most material. So for John, he can make more donuts and he can make more cupcakes, so maybe he just has a bigger shop. But for comparative advantage, it's who gives up the least. Always remember that. It's who gives up the least. And so if we go to cupcakes, John gives up 2 donuts, Erica gives up 3. So clearly, John has the comparative advantage in cupcakes. Now for donuts, John gives up half a cupcake, whereas Erica only gives up 1/3, so she has the comparative advantage here. Okay? And that'll probably answer most of the questions. We might have to come back and check some more. So let's see what they want to know. All right, so it says, who has the absolute advantage in producing donuts? Well, let's look at the donuts. We already said that. And we have to explain why. And we can say John. And the reason is 200 donuts is greater than 150. That's all you have to say. Then inequality will explain it. Now, who has the comparative advantage in producing donuts? We already discussed that also. The comparative advantage is Erica. And we can say she has the lower opportunity cost. And we can then also put the fraction there. We can say 1/3 is less than a half. Those are the 2 numbers we were comparing. Then for part C, it says, assume that John and Erica decide to specialize according to their comparative advantages and that 1 cupcake is exchanged for 4 donuts. So this is a terms of trade question. So when it comes to terms of trade, I want to focus on how you want to figure this out. When it comes to terms of trade, in order to benefit both John and Erica, you would have to pick a number that's between their opportunity costs. So we would have to say 1 donut for, and it would be any number that was less than a half but greater than 1/3. Anything in there would be fine. And if you had a common denominator, here we would have 3/6 and 4/6, so 5/6 would be good. Now, I'm not going to spend too much more time on this one because the terms of trade they give us is, it says 1 cupcake for 4 donuts. So here is what they're giving us, and they're saying, is this a good deal for somebody? So even though I just explained on this one, terms of trade, you want to pick a number that's between the opportunity costs. This question is really putting us over here on this side because they're telling us it's 1 cupcake for, so let's analyze this one instead. So I'm just going to bring this down here. So here's what would work. What would be beneficial for both would be 1 cupcake for, and it would just be any number that was less than 3, number of donuts less than 3, then greater than 2. Like 2.5, that'd be perfect. Okay, that would benefit both. But they give us 1 for 4, which is typical. They're going to give you one that is not between. But you have to figure out to who does it benefit and who does it not. So here's the rule. If in between would benefit both of them, then the number they give you is who does this still satisfy. So since it's a 4, I'm going to put a 4 in here. So if I took a 4 and replaced donuts with 4, 4 is greater than 2. So that's good for John. 4 is not less than 3. It's bad for Erica. Now, if you want to push it a little bit farther, Erica's 1 cupcake is worth 3 donuts. And so 1 cupcake for 4 donuts, she'd be better off just doing it herself. 3 donuts is a better deal for her. 1 cupcake for 2 donuts, and you're going to get 1 cupcake for 4. That's a great deal for John. So if sometimes talking through it actually gets a little bit confusing, if you want to keep it simple, just remember, benefiting both has to be a number that fits between the opportunity costs. And if you give a number that doesn't do that, just which situation does it satisfy? And 4 is greater than the 2, but it's not less than the 3. So it's satisfying John, not Erica. So the way I would say this on this one is indicate whether or not specialist trades are benefit to John. Yes. That's all they're requiring us to say. And then for 2, for Erica, no. So we don't even have to explain. It's pretty short there. Now it says, assume that Erica discovers a new cupcake production technique that will increase her daily production of cupcakes only. Using donuts on the horizontal axis, draw a correctly labeled production possibilities curve for Erica before and after. Now before I draw the correct answer for this one, I actually want to come back over here and show you how this question could have been presented, just for practice sake. So even though this was written, or it was given in a trade table, they could have just written it in a paragraph, but they also could have done this. They could have just given you a picture. And the picture could have looked like this. They could have said, okay, we're contrasting donuts to cupcakes. And the donuts here, they could have given you a value at 200 and 100. And then for cupcakes, they could have done 50 and 100. And for John, he could make 100 cupcakes or 200 donuts. And for Erica, it would have been 50 or 100. And 50, oh, this is a 150, not a 100, right? Okay. And so then they would have just pointed to this one and said, this was John, and they would have said Erica. Now they could have presented the information like this, and then had you do the problem, and you would have had to have placed this information in there. They didn't, but they could have. So just keep that in mind. So for D, what they're saying is, they're saying just put Erica on here, and then just show what happens if she gets new technology that enables her to make her daily production of cupcakes improve. So if we just go to this one right here, and we say, well, let's give her point at 150, and let's give her this point at 50. So this is what was happening, which really is just the bottom part of this graph here. And then she has some new technology that's allowing her to make more cupcakes, but it didn't affect the donuts. So we're just going to make an ambiguous point up there. We don't know what it is, and then we're just going to connect it here. Okay, so that just shows that there was an expansion here, but this stayed the same. That's all they were looking for. Okay, so a little review of trade tables could easily come up, you never know. And that is question number 3. And there is all 3 questions for AP Macro, the year 2016. All right. Thanks for watching. We'll see you guys next time.